Alright, how are you all students? This is a tutorial platform for Applied Maths 3. Under this tutorial, we will solve different problems related to the contents and grasp the main objective of the course. As usual, those who didn't subscribe, I strongly recommend you to subscribe this channel as many tutorials are uploaded from now on. Hence, to get them on time, subscription is highly recommended. So having said this, let's dive into the content. As you all know, Applied Maths 3 starts from the first chapter saying first order ordinary differential equations. So here we are going to see different kinds of solution techniques in order to solve ordinary differential equations of first order. So at the beginning we must have something we need to learn about, and these are order and degree of differential equations, solutions of differential equations. So let's now directly begin from the first question. So the first question is about, you see, order and degree of first order differential equations. So the first one says find the order and the degree if any of the following. So let's find the degree and the order of the following differential equations. So the first one is this: 9 times the 4's cube, or the 4's power of d cubed dy dx cubed minus 2x dy over dx the power of 6 minus x equals 0. And here you are asked to find the order and the degree. So how are you going to find the degree of this one? The degree as well as the order. Students, you have to know about order and degree first. The order of a given differential equation is the order of the highest derivative involved. So if you just try to observe this differential equation, as you see, we do have two derivatives here. One is done for 3 times and the other is done one time for only once. Hence, as can be shown from this one, the order of, you see, the higher derivative here is 3. The order of the higher derivative is considered to be the order of the differential equation. So the order of this differential equation is 3. And the exponent corresponding to the higher derivative, as you see, is 4. And this represents the degree. So clearly, the order and the degree of these differential equations are 3 and 4, as can be shown here. So the order is 3 and the degree is 4. Let's come to the second one again. Have this place. Here clearly we can understand that the order of this differential equation is 2, because we are having the dependent variable y being the derivative twice with respect to the independent variable x. So the order of this one is clearly 2. But in order to determine the degree of this ordinary differential equation, what we need to do is, first we need to create a means of writing this in terms of polynomial form. So to do that, we have to perform this one as follows. So the solution goes like this. Look, this is a problem we were having, so we can rewrite this one in terms of this. d squared y over dx squared, the power of 5 over 3, and the 4's power of the second derivative of 5 with respect to x squared minus x, the power of 1 over 2. What I did here is, the square root is taken to be a power of 1 over 2, as you see. So everything is straightforward. Now we need to create a means of having exponent of natural numbers here. So for that to come, let's consider 3 and 2. The denominators 3 and 2 to have a common least multiple 6. So let's take a power of 6 expression both sides. So as I am taking a power of 6, 3 times 6, 5 times 6 is 30, 30 divided by 3 is 10. So this will be 10, and this will be, when we take the power of 6 here, we do have 1 over 2 times 6, which actually is 3. So this is going to come. This will be a power of 10, and this will be power of 3. As can be shown here, this binomial expression must be multiplied for 3 times. And now, as you are multiplying this for 3 times 4 is going to come. And 3 times 4 is going to be 12. So when you leave the rest, the one with the highest derivative or with the highest order is going to be this one, students, with the one we having exponent 12. So the degree of this polynomial, this differential equation is going to be 12, as it is written here. And the order of this one is 2, as it can be shown here. So the order is 2 and the degree is going to be 12. And next from this we have also another one. Let me consider this one, the differential equation having this form: y second prime minus 8y equals to 1 over 5th power of y second prime squared minus 2x y first prime. So again, this is not written in polynomial form, so it's up to us to rewrite this in terms of polynomial form of dependent variable and its dependent variable derivatives form. So to do that, here we are having 1 over 5, so let's take a power of 5 expression for both sides. So as we are doing that, these 5 can directly go to this, but this, when we take the power of 5 of this expression, 1 over 5 times 5 goes to 5, so it will be like this. Now, as can be shown here, no need of performing the product of this for 5 times. We can easily analyze that this will have a power of, you see, 5 for the first term. So even though these two are having same order, the highest exponent is going to be number 5. So this shows you that the degree is 5. And when we come to the order of this differential equation can easily be obtained by looking the highest derivative involved within the d. So the highest derivative involved here is 2, because we are having second derivative to the left as well as to the right, even first derivative again together with second derivative to the right side. So we have to choose the higher one. The higher one is, you see, done for, you see, second times. So the order is basically 2 and the degree is 5. So this is obviously true. Now what follows is the fourth one. The fourth one is y, as you see it is stated here. So in order to determine again the order in the degree, first let you observe that you see the highest derivative involved here is 3, because as you see here it is done for 3 times in the case of this. Again it is done here, you see, 3 times. The dependent variable y has been derivated 2 times here with respect to the independent one. Here we are having, you see, third derivative of y with respect to x. Because of this, the order is the highest derivative involved in the given differential equation, so the order can be 3. The question is, how can we determine the degree? Because this is not written directly in terms of polynomial form of the dependent variable and its derivative. So we have to create a means of writing this in terms of polynomial form of the dependent variable and its derivative. To do that, let's bring or take this radical expression to the right. So one can have this expression. So here, instead of having this radical, let's take 1 over 2. Again, as we did before, we do have 2 denominators 3 and 2, taking the least common multiple as 6. Let's take a power of 6 of the left expression and the right expression. So as we are taking a power of 6 of the right expression, 6 times 6 makes 36. And here 2 times 6 is going to be 12. 12 by 3 is 4. So the expression inside the bracket will have a power of 4, whereas this one is 36. But as you are coming here, you see, when you take a power of 6, 3 is going to come, because 6 divided by 2 is 3. Now, finally, what's going to come is the following one. You see, students, 36 is going to appear here, and this is going to be 4, as I said, and this is 3. Now, without performing any sort of further, you see, mathematical manipulation, one can easily identify the highest exponent here. Look, this is going to be multiplied for 4 times, so this makes 3 times 4, 12. But in addition to having this 12, we do have 36 outside. So 36 plus 12 is going to be considered because the bases are the same. According to the exponential rule, we can add the exponents. 36 plus 12 makes 48. So clearly, we can understand that 48 is going to be the degree for this one. When you come to the right side, as you are multiplying this 3 times, here you do have 5 times 3, 15 is going to come for the exponent for this particular expression. So having 48 over here, however we can say, or we can take that 15 is the degree. We can't. So because of this, 48 is considered to be what? The degree, and the order is going to be 3 for this particular example. Mind you, dear student, that In a certain differential equation, always order exists, but it is not a must for the degree to exist. I hope you have understood the idea in a better way. Hence, as can be shown, the order is 3 and the degree is 48.